Hi, I'm Donald McIntyre, founder of Etherplan. I research, write articles, and podcast about Ethereum Classic, Bitcoin, and decentralized applications. This series is Getting Started with Ethereum Classic, section How It Works, and I'm going to read the article Ethereum Classic Gas System Economics Explained. This is episode 15 of 50. Ethereum Classic Gas System Economics Explained. One of the brilliant inventions of the Ethereum blockchain standard, which is the underlying protocol in Ethereum Classic, ETC, is the Ethereum gas system, which solved the halting problem in secure, distributed, Turing-complete computing networks. As Bitcoin accepts a very limited, specific, and simple set of transaction types, all nodes and miners in the network just accept those transactions based on their structure and post them on the blockchain after hashing and validation. For transactions to be accepted and hashed by miners, users need to send them with a fee that is paid to them. However, regardless of the fees paid to miners or the volume of transactions, each block in Bitcoin has a fixed size in megabytes and weight, as per protocol, that determines the amount of transactions that fit in a block. The problem with the Ethereum standard is that it stores software programs that are executed by what is called a shared virtual machine by all nodes in parallel in the peer-to-peer network. Those programs can be very complex and diverse. In computer science, when programs become complex and diverse, they may sometimes have processes or bugs that either don't finish computing and/or that cause a host machine to run indefinitely without delivering a result. It is a similar problem as when your laptop starts the infinite spinning wheel and you have to restart it. The Ethereum specification, as per its yellow paper, determines a list of operations the Ethereum virtual machine, EVM, can compute. Developers and users then enter and store software programs or smart contracts based on those defined operations, or opcodes. As these programs can be complex, consume a lot of time and computation, or can create the halting problem, the yellow paper also specifies a maximum amount of computation each opcode can consume. Just as humans many times work and get paid by the hour, for example, 8 hours a day at X dollars per hour, or Y dollars per hour for consulting, or lawyers charge Z dollars by the hour, the computers in the Ethereum protocol charge gas instead of hours. This gas is determined per opcode in proportion to the complexity and demand in computing effort. For example, just as a lawyer would charge 10 hours to draft a contract at $75 per hour, a computer in Ethereum would charge 32,000 gas at 0.00000001 ETH per gas for a G-create operation. So, the design is brilliant because it solves the halting problem in a peer-to-peer computing network, efficiently allocates scarce computing resources in an Ethereum-based network, prevents network abuse as the computers in the system charge a fee in exchange for their work, imposing a cost to potential attackers. Physical and economic constraints. However, the last problem the system had to solve is that it needed to establish a limit to all the transactions or computations it could take per block. This is because in a global computer peer-to-peer consensus blockchain, there are a set of constraints that bound its efficient and secure operation. 1. The time it takes to propagate transactions and blocks. 2. The time it takes for the same transactions and blocks to process locally in each computer in the network. 3. The fee levels per transaction. And 4. The total size of the database or blockchain as blocks are added every 15 seconds. In searching to solve this problem, the choice of the Ethereum designers was to have miners, who are the block producers through proof of work, set the limit of each block by signaling a block limit to the network. Once all miners agree on a limit, then they all accept transactions up to that amount to build new blocks. Using this system, as the Ethereum network increased in popularity, the history of the gas limit per block, which is analogous to block size, has been increasing steadily as miners felt comfortable with block size, propagation times, and their fee levels. Recently, they made their last increase to 10 million gas per block. The node count versus miner tragedy of the commons. However, one of the problems the gas system has created for the Ethereum network is that as miners have been enlarging the block size by increasing the gas limit, the chain has been running the risk of decreasing its node count, a critical security metric because for new users to synchronize new nodes, it is becoming too big of a task given average bandwidth rates in different parts of the world. What this situation is indicating is a sort of tragedy of the commons scenario, that miners in Ethereum are evidently managing very well constraints 1, 2, and 3, as explained above, because they benefit them directly and in the short term, but are not as concerned with 4, the total block size, thus lower node count in the network, even if those undermine the network in the medium and long term. Implications for Ethereum Classic. As Anthony Lusardi said, Ethereum Classic, as another implementation of the Ethereum protocol, has the advantage of hindsight, so he has introduced ECIP 1047 to mitigate this issue by requesting that miners target a gas limit of 1 million gas, which is an 8 times reduction from the current limit of approximately 8 million. I agree to lower the gas limit in ETC. My rationale is that it seems there is a loophole in the gas system. There is a sort of conflict of interest where miners are incentivized to increase the gas limit on one hand, but also to limit it up to a point where they believe they will win the race to earn the rewards and fees per block and propagate their blocks as soon as possible, as only one wins every round. That limit seems to have been 8 million gas for a long time, but recently in the Ethereum network, they increased it to 10 million, even if there is ample evidence of network bloating and decreasing node counts. In fact, from more than 15,000 nodes a few years ago, the network is currently operating with around 6,500 nodes at the time of this writing. However, miners don't care about node count or bloat. In other words, that 8 or 10 million gas limit is only for miner efficiency levels, not for node count maximization. The 8 or 10 million gas limit is evidently, as seen empirically, not a desirable block size for full node users, developers, and enterprise to download and operate nodes. This is why all are using risky trusted third-party node and hosting services such as Infura and AWS. The problem seems to be that block processing and propagation efficiency points are not equivalent to node size, syncing time, and thus node count efficiency points. Both points are different and the miner optimal point is higher than full node optimal point. This is the loophole in the gas system and the general misalignment of economic incentives. What solutions can be debated? In Bitcoin, Satoshi solved the block size problem by establishing an arbitrary limit at 1 megabyte in the early days. This does not delegate to miners or any other party other than the whole ecosystem by rough consensus the setting of the block size. In the case of Ethereum Classic, ECIP 1047 is proposing a suggested gas limit of only 1 million gas that miners have to agree to. Perhaps that level is too low. At 67,000 gas per transaction, which is the average cost per transaction I calculated since Ethereum has been operating at almost full capacity, starting in August 2017, that would imply less than 86,000 transactions per day, which would be too restrictive in my opinion. The 8 million gas limit at 67,000 gas per transaction is 680,000 transactions per day, and Ethereum has been floating at around 750,000, so that seems to be the transaction capacity per day for this design and gas limit levels. This is also competitive with large value settlement systems in the fiat world, such as Fedwire and CHIPS. As Ethereum is moving to Ethereum 2.0 and the Constantinople and Istanbul upgrades don't seem to have significant scaling solutions, it seems ETC has to start working on its own scaling research in the Turing complete plus proof of work plus fixed monetary policy segment. It seems one part of the solution is to not have miners decide the block size in the first place, and to set it at a certain point that is optimal for both miners and new Sing node operators. To be able to execute relatively complex transactions with as little gas as possible while keeping a higher transaction count, to have a block size hard fixed as Bitcoin does at say 4 million gas limit would perhaps benefit full node operators and also miners because fees would be higher. The problem is there needs to be a way to enable 680,000 transactions or more per day with a 4 million gas limit. That is the next problem to solve. Thank you very much.